All right, part two, special right triangles. Hopefully, this is still a review from your um, geometry days. The biggest thing is that all the directions are always going to be exact, no decimals, only simplified radicals. Because otherwise, you can type a lot of this on your calculator. You can steal from sine, cosine, uh, tangent, that kind of thing. So, what I want you to remember is there are two types of special right triangles. There's a 30, 60, 90 right triangle. So 30, 60, 90. What we then remember is we have this, it's always going to be in the ratio of 1, square root of 3, and 2 as the sides. There's always going to be some ratio of that. And then there's also a 45, 45, 90 right triangle. And the reason that matters is because their sides are always in the ratio of 1, 1, square root of 2. So what we do with that information is imagine then we know what sides we got, right? So when it says find the exact value of x, yeah, if we're given the 30-degree side, we see that this is the adjacent and this is the hypotenuse. So we go up to our other special right triangle, we find the 30 side, we find the adjacent side, we find the hypotenuse side. So we know from basically saying that the cosine of 30 is equal to the square root of 3 over 2, we can say, so square root of 3 over 2, we can say from our base triangle, square root of 3 over 2 is equal to adjacent over hypotenuse, x over 8. And then we can do some cross multiplying and dividing. So if we'd have 2x equals 8 root 3, right? And then we divide both sides by 2, and we get 4 root 3 is the answer we're looking for. So basically what we're going to do is compare similar triangles of 30, 60, 90 to original special triangles. Same thing for 45, 45, 90. So if this is adjacent and this is hypotenuse, then we're over here looking at a 45 and we go adjacent, hypotenuse. So if we're looking at on the original triangle, so the reference triangle that I have above in the notes, cosine of 45 would say 1 over root 2. And then in our problem, the adjacent over the hypotenuse is x over 6. So now if we cross multiply and do something like this, then we can say x is equal to 6 over root 2 divided by root 2 over. That being said, we don't like radicals on bottom. So we can have 6 root 2 over 2, divide top and bottom by 2. And this is what we're going for, 3 root 2. I think I got some more practice on the next page. So, yep. All right, just for fun, I'm going to draw up 30, 60, 90 reference triangle again. So the short side, the opposite side of 30, square root of 3, 2. Some of that you just got to commit to memory. 45, 45, 90 triangle. All right, and then let's see how many of these we can rip through. So it would appear to me that this is going to be a 45, 45, 90. The reason I know is if this side and this side are isosceles, then this angle and this angle have to be the same. So if we do 180 minus the 90-degree angle, we're left with 90, and we divide by 2, it's 45. So say we want to use this reference angle and do this as adjacent to the hypotenuse, So we do the reference triangle of the 45 of adjacent to hypotenuse, and we do 1 over root 2 equal to x over, from the problem, x over 2 root 2. And then we go 2 root 2 equal to x root 2. Divide both sides by root 2. We end up getting 2 equals x. All right. So same reasoning as before with the isosceles triangles, both having the same side. Our reference triangle's got to be 45 and 45. So if we want to do, let's change it up. Say we're using this as a reference angle. So we use this as opposite, and we use this as hypotenuse. Our reference triangle would be 1 over root 2. And then our problem would say root 2 over y. So we get y equals root 2 times root 2 is 2. So we're already done. How about that, joy? Okay, so 30, 60, 90 triangle, call this adjacent and call this opposite. So we're thinking tan now, TOA. Reference triangle of opposite over adjacent from 30, opposite, adjacent. So 1 over root 3, problem triangle, ratio opposite over, so we have x equals 3. Because this times this equal to this times this. All right. So, if you notice, this is 4, this is 4, and 2 plus 2 is also 4. So we actually have an equilateral triangle. So this is 60, this is 60, this is 60. And there is a right triangle. So if we go a smaller triangle, we got 30, right? So let's say we use this as a reference angle and then just look at just this triangle, right? That makes this opposite and this hypotenuse. So let's go to a reference of our 30, 60, 90, and we'll go, okay, we want to turn this into opposite of 60, this into adjacent of 60, and this into the hypotenuse of 60. So we go opposite over hypotenuse. Square root of 3 over 2 equal to problem triangle h over 4. And we'll have 4 root 3 cross product equals 2h. Divide both sides by 2. We're at 2 root 3 equals h. All right. Okay. This is the end of video 2. We'll have video 3 to wrap it up.